Hello everybody and welcome back to Maths Miss Buick. We're still focusing on differential calculus, and this video we're concentrating on trigonometric derivatives. So here we have three rules, and all three of these rules will be found in your log tables under the section differential calculus. It's important that you understand the rules and know where to use them, but you don't necessarily have to learn them off. So here we have sin x goes to cos x. Cos x, we differentiate cos x, it goes to negative sin x, and we differentiate tan x, it goes to sec squared x. So let's begin by looking at our first example, example A. So here we have f of x is equal to cos 7x squared negative 1. So we'll begin by writing our f dash of x to tell the examiner that we are differentiating our function. So we look at the cos and we say, well, what does cos go to? So cos goes to negative sine. So there's our negative sine. We don't write down the x because the x is represented by our bracket. So we put down our bracket instead. And then we differentiate the bracket. So if we differentiate 7x squared, well, the 2 goes to the 7 and multiplies, so we get 14x. And of course, when you differentiate negative 1, it goes to 0. And then to finish off the question, to tidy up, you bring your derivative of the bracket to the front. So don't forget the negatives here on the sign. So 14x sine 7x squared negative 1. So that's the first answer. So the rule is you change your trigonometric function to its derivative, so which was a negative sign here. You write down the bracket and then you differentiate the bracket. And then bring the differentiated bracket to the front. Okay, on to example B. So let's write down a notation f dash of x. We're going to carry out the exact same format again. So we look at the tan and we say, well, tan, when you differentiate, it goes to sec squared. So there's our sec squared. And we write down our bracket. And then we find the derivative of the bracket. So if we differentiate x squared, we get 2x. And if we differentiate 9x, we get 9. And then we'll bring this to the front. So we have f dash of x is equal to 2x plus 9. Let's put a bracket around that. Sec squared x squared plus 9x. And that's the answer to example B. Again, you can see here, I changed our derivative of our trigonometric function to sec squared x. I wrote the bracket down and then I differentiate by the bracket and bring it to the front. So it's the exact same, I suppose, as a pattern over and over again. Now let's look at our example number C, or letter C. So this time I picked this example because we've got thetas. So you're not going to have always x's, so it's important that you can differentiate with either x's or thetas. So let's begin by using our notation. We can see there's a 2 in front. So in this case here, if there is a coefficient in front of your sine, your cos, your tan, you keep that. So there's our 2. Well, we know sine goes to cos. And then we have our 3 theta. And then we differentiate by the bracket. So if we differentiate 3 theta, we get 3. That's the first part done. Moving on, we've got cos 2 theta. So if you differentiate cos, you get negative sine. So negative sine. We write down the bracket, which is 2 theta. And then we differentiate by the bracket, which is 2. So let's put this together. Well, we'll bring the 3 to the front and we'll multiply that there. So we have f dash of theta again. So, well, 2 by 3 is 6. Cos 3 theta there. And then let's bring our 2 to the front. So negative 2 sine 2 theta. And we're done. That's number C, or letter C. And now on to our final example in this video. So we can see here that we've got f of theta is equal to cos 4 theta minus sine theta over 4. So let's begin this question. So we're going to do f dash of theta. So we know that cos goes to negative sine. There's our 4 theta. And we differentiate by the bracket. So if we differentiate 4 theta, we get 4. On over here, well, you can see here that we've got theta over 4, and we're going to have to use the quotient rule here on this because it's a fraction. But let's deal with the trigonometric function first. So we have negative cos. Well, we know that cos goes to negative sine, so negative sine by negative is a positive, so it'll be plus sine theta over 4. And we have to differentiate the bracket, which we know is going to be the quotient rule. So let's do that out separately in rough work. So we have to differentiate theta over 4. Well, we know that our numerator is our u and denominator is our v. So we have our rule, which is v du dx minus u dv dx all over v squared. It's just rough work here. So let's work out what is our u, our v, our du dx, and our dv dx. Okay. Well, our u anyway is our theta, because that is labelled already. Our v is our 4. So when you differentiate du dx, so if we differentiate our theta, now pretend that's an x. If that was an x and you differentiate it, you get 1. Same with the theta, it goes to 1. And then our dv dx, well, we know that constants go to 0, so basically it's 0. So let's put this into our quotient rule. So our v is our 4, our du dx is 1, negative u, which is theta, and our dv dx is 0, so that'll be gone to 0. All over v squared, and v squared is 4, so 4 and we square it. So we tie it up, we've got 4 by 1 is 4. We know this is going to go to 0 because anything multiplied by 0 is 0, all over 4 squared, which is 16. And if we break it down, we get 1 over 4. So let's go back now and put 1/4 into where we had our QR, which is our quotient rule. So instead here we're putting in 1/4. So let's finish off our question by tidying it up. We bring our 4 to the front, and don't forget the negative here on the sign. So there's our 4 sine 4 theta, plus bring our 1/4 in front, sine theta over 4. And we're done. So there's 4 examples of using trigonometric derivatives.